Hello, everyone. Thank you for being invited here by Mr. Chairman, Professor Mikulski. Thank you very much. We are from company Vasco SA from Gliwice, and we are IT integrator specialized from more than 5 years in developing and delivering to the city ITS systems. Not only that, our engineers, after these few years of working on ITS in a quite big city, Wrocław, discovered that there should be done some additional developments based on our experience to simply save money for the city and make more safety work of the trams, and as well to optimize all the traffic in the city and make more fluent the traffic of the trams inside this agglomeration. Please, next slide. Due to this, our engineers design a special digit called Cyfra, and the digit is fully integrated in the centralized mode system from our partners company Gertrude from Bordeaux. And the digit is working with the system through the PLC controllers on the junction. So more technical data will give you my colleague, Mr. Ust Czarnecki. This is also supported in the future probably by the grant, special grant from the European funds. And if this technology will be approved finally on the junction, this is already working more than a few months. And the results are quite positive, I can say. Then when the city will be getting money for that, then we will try to implement that solution into the city, in the full, all of the tram junctions. So I will pass the microphone to my colleague. Thank you.
Dzień dobry.
Good afternoon. I'd like first to start what's the origin of the problem and the origin of the device. During the ITS implementation that was a few years ago, we based on the detection system, which right now is to be successively changed into V2X connections directly between public transport vehicles and the intersection infrastructure. In the previous version, actually, the solution which could have been used during ITS, we based only on classical detectors. There was a detector far from the intersection, detecting the passenger of a vehicle, a detector directly at the vehicle stop line to know that the tram has passed the intersection or not, and to make the traffic smooth. What was the objective of the project? That was priority for public transport trams, and our job to make trams moving smoother and faster through the traffic lights. So at that moment, when detecting a vehicle approaching the intersection, the green light had to be on with some advance, so that without braking or a minimal slowdown could freely cross the intersection. This strategy makes that in advance, we have to give the green light for the tram. So actually, when the moment will not be assigned, the tram could be safely brake and stop before the intersection. In overall, this results in a time loss at the intersection related with the priority giving, because the phase of traffic for tram is artificially extended by the fact that within advance we've got to give the go signal. Based on the statistic that we've been collecting in this system via detection of the tram on the stop line, the system has statistics related with what advance the green light is given for the approach to the stop line by the tram. And the French, what French engineers wanted to improve the regularity and smoothness of the tram traffic. We have direct relationship between the driver's behavior and the system behavior. So we are directly related whether the driver will maintain a smooth traffic or not. There's such an interaction, and the learning of this system was necessary to obtain as good as possible effects of operation or to reduce the time losses. And this is an example of statistics showing we've got the number of trams passing the intersection. Horizontal line is the length of a traffic light, green light, allocated for the needs of a tram passing the intersection. What the engineers wanted to achieve, to have a quasi-normal distribution graph, to notice that actually most passages through the stop line was in second 5 or 6 of the green light. And how the phase of movement is prepared. Based on tram detection, the system prepares the phase of movement, verifies whether there's in collision relationships in others, then normal the safety time is started, and then the phase for tram is started. What we want to achieve is we've implemented this solution that are used in the Western market mainly, where via such signaling devices, drivers are informed what they could expect in the intersection. What was our aim is an innovation in our solution, that the signals that are displayed that prepare the phases of movement would be displayed for the drivers during the implementation of intergreen times. So we've integrated fully our digital solution with the controller to guarantee safety of the system. So when we start displaying 4, 3, 2, 1 and the green light, so that he would be certain that he'd had this green light, because then he would not stop. In the display, which we've agreed with the traffic manager using the permit for traffic or VMSs, it's not considered as a road signal, but as a possibility of displaying via VMSs auxiliary information for drivers. In this way, we matched the Polish legislation to be capable to install this displays on site and to show signals for the drivers. On the left-hand side, we've got the information related to the prepared phase of movement. Via the triangles we show directions, permit to left, forward or right. In the case when we don't recognize the vehicle, square is shown. C stands for detection basic detection of the vehicle, then countdown of the sequence given by the traffic engineers from 5 or 4 or 6 seconds, and it's successively counting down, and automatically after the countdown the traffic phase is started, green light for the tram. To illustrate the closer end of green light, we display the K symbol, which shows that it's the end of this phase of movement. I'll go back to the previous slide. This system has a preset minimum and maximum time of the green light for each block, for each intersection. The traffic engineer determines how long we can wait for a tram passage. This is related to the aim to limit the freedom for drivers who sometimes moved across intersection not related to other traffic users. And here are examples of signal sequences which are displayed on the display. At the moment of giving the priority, the direction display, this triangle starts blinking to inform that he'll get the phase in a special system. I will be helping him to pass the intersection. What was the origin? After the observation of the traffic manager, a number of rules were introduced related with the degradation of priority. They've noticed that if too much assistance to the public transport, then there are problems with vehicle queues. Some people suffer, and they've introduced a number of rules that if the queue length exceeds specific parameters, then the priority is switched off temporarily. And it meant that drivers were not aware whether they will pass the intersection with support or not. And the application of this display is very helpful. As our job was to implement this system on site, we've got two ways of connecting this device. We use dedicated communication along the power supply line to reduce the number of necessity to install additional infrastructure, and or via Ethernet communicate this device with the controller. At the end, I'd like to present the test results, because the device has been working for a year as an agreement between our company as a city, as a research project, and we've installed this device for two directions, with a stop and without a stop. In the table on the left-hand side, we have the information from before and after starting the device. What we were interested, first, to reduce the number of green phases without passage of tram, i.e. such situation that the tram would not catch up for the green light. That meant that the trams were initiating the phase of traffic, the tram couldn't pass, and then the system, after detecting, gave the permit to pass for the second time. And by the application of such auxiliary system for drivers, we've reduced by half the number of such cases where actually the drivers have not reached the intersection. The second issue that we've improved is the time related, how long they've got to wait to pass the intersection. i.e. we've accelerated since the moment of tram notification until its passage through the intersection. We've reduced the time by 30%. For me, it means that I've got more time to give the permit to pass for other traffic users. On the right-hand side, we've got the statistics graphs. We see the frequency of passing the intersection by trams for individual times of a green light. When we started the test, we could find various irregularities, and the vehicles were moving anyhow. That affected other traffic users. Once and the device was commissioned and implemented on site, we don't have an ideal graph that would show that regularity and passage through the intersection has increased, but the situation has substantially improved. Also, we carried out a specific campaign among drivers who very positively responded to such device on site, which helps them to pass the intersection, and that's related to the fact that they don't need to look at the phases, they don't match the vehicles in the traffic, because they pass through the intersection, they know what is the traffic organization, and without looking at other lights, they will get the permit to pass. Now we wanted to focus on the cooperation with this device and passing the intersection using this device. That would be all I'd like to say.